Okay. So I was just starting to, I was just commenting that I've really seen the development of this subject just about from the beginning. And so I'd like to reminisce for a couple of minutes. Back when I started teaching astronomy many years ago, the best image of the Ring Nebula was this color photograph from the Hale 200-inch telescope. And we taught our students that the Ring Nebula is a hollow sphere. In fact, if you ask Google this question, they'll tell you that the Ring Nebula is shaped like a ball, and the reason it looks like a ring is when we look through the edge, the shell is thicker, and looking to the center, there's less material in the line of sight, and this gives the impression of a ring. Well, with the development of the Hubble Space Telescope in particular, which has had a tremendous impact in this subject, we can see details in the Ring Nebula that were not visible from the ground. In particular, this huge number of knots. And if you zoom in, I think even a high school student can tell you we're not looking at a sphere, because look, all these dust knots are around the edge, and there are practically none silhouetted against the center. So you can tell just by looking at this image that we're looking at something like a cylinder and not a sphere, and we're looking roughly along its axis. Now, and this has made the news, even in the business news, that the ring is a lie. It's not a ring after all. Now, back in 1976, Bohdan Paczynski introduced the idea of the common envelope interaction. And in particular, he said that observational discovery of a short period binary interplanetary nebula would support this picture. Well, I was unaware of his paper at that time, but almost literally the same month, I discovered the eclipsing central star of the planetary nebula Abell 63. Well, I didn't discover it. Dorrit Hoffleit discovered the eclipsing binary in 1932, and all I did was identify it with the nucleus of the planetary nebula, actually on a cloudy night up on Kitt Peak in the library. So here's a light curve we obtained for the central star. The orbital period is 11.2 hours. Now, this was done back in the days when you had to be out at the telescope on a cold night doing photoelectric photometry. You young people have it easy these days. Now, here's a modern image of the planetary nebula, Abell 63. And so we see kind of a barrel-shaped structure, which we're seeing edge on. And then there's been an outflow along the axis, which we can see in this deep image. You see these, I guess, are we calling these ears now? What are we calling these? Anyway, there's a long axis from this object. Now, if we were to be viewing Abell 63 along the axis, we can argue that it would look like the Ring Nebula. Well, actually, there is this object, which has a 2.9-day binary central star, which I think we are looking at along the axis. And in agreement with that, the photometric amplitude of the variations is very low. Well, anyway, here was the status around 1990. There were about a dozen planetary nebulae with close binary nuclei, periods ranging from 2.7 hours up to 16 days. Since then, of course, dozens of objects like this are known. We had the APN1 conference that I was at, organized by NOAM, and the field is really exploding, as we're seeing this week. So let's go ahead then to the talks.